And welcome back, friends, to Cajun Coding. This is St. Raz, and we are currently on our little adventure in learning Python 3 with the assistance of the Solo Learn learning app and the Mimu emulator, allowing my laptop to function as an Android smartphone. The last lesson that we went through was list operations, and now we are proceeding on to list functions. And list functions. Another way of altering lists is using the append method. This adds an item to the end of an existing list. So in the example here, nums consists of the integers 1, 2, and 3. Nums dot append, and then inside parentheses 4, and then we print nums. So as you can see, the value, the integer 4, is added to the end of the list here. And you notice we accomplished that using the dot operator there. So the name of the list that we are modifying, the dot, and then the name of the function that we are calling. Some functions will take arguments, some will not. This particular function needs to know what we're adding, so we put the 4 in there, and there's our result. And what is the result of this code? Words, and that's going to contain a single string, hello, words dot append, and then inside the parentheses there, world, and then print words 1, and it should put out world, I would think, and it does. List functions. To get the number of items in a list, you can use the Elian function. Pretty obviously, Elian is an abbreviation of length. So we have nums 1, 3, 5, 2, 4. Notice that those are 5 items, so print len nums, the result would be 5. Unlike append, len is a normal function rather than a method. This means it is written before the list it is being called on without a dot. So, functions and methods. So a normal function, len, and then inside there is the object that we're calling that function on, but it does not use the dot operator. Let me see, what is the result of this code? Letters equals A, B, and C, letters append D, print len, letters. This is just returning the length. We have 3 items, we just added 1, so the length would be 4. List functions. The insert method is similar to the append, except that it allows you to insert a new item at any position in the list, as opposed to just at the end. So we've got a list here, words Python5 index equals 1. Oh, I see. So words insert index. Is it a dot? I think it is. No, it's not a dot. That's a comma. It's kind of hard to see here. Index comma is, and then print words, which is our list, and it comes back Python is fun. Now what we're looking at here, when you call insert on a list, we need to specify 2 parameters. The first parameter is going to be the index that you're going to insert the new element, and then the second argument is going to be the element that you're inserting in that spot. This is an integer. This is an index, is the index that you want to insert the item. In this case, what they did was we're using the variable name index, which contains an integer. This would work the same if we just put the integer 1 there, but this is just a little practice using variables there. As you can see, you can use a variable in place of whatever type of data that you need. If you need to put a string somewhere, you can use the variable name instead of the string. If you need an integer to pass as an argument, like we just did, instead of putting the integer, you can put a variable name there. As long as that variable name contains an integer, then the code will work fine. And what is the result of this code? Nums 98765, nums append 4, nums insert 211, and then print len nums. Now we've got 1, 2, 3, 4, so we got 5 items. We're going to append 1 and we're going to insert 1. All we're asking for is the length. So if we have 5 and then we add 2, that would be 7. What the values are doesn't really matter in this case, so it would just be 7. The index method finds the first occurrence of a list item and returns its index. If the item isn't in the list, it raises a value error. So this is our list consisting of single character strings. Print letters index R. We do have an R, and it's 0, 1, 2, so it would return 2. Print letters index P, the very first item, which is 0 index, so it's 0. And then print letters dot index, and we've got Z inside the parentheses and single quotes. There's no Z here, so it returns value error. Z is not in the list. And this enumerates a few more useful functions and methods for lists. Max returns the list item with a maximum value. Min returns the list item with minimum value. List.count object returns the count of how many times an item occurs in a list. List.remove object removes an object from the list. And then list.reverse reverses objects in a list. Now usually it's kind of common sense as to whether you're going to have to pass in values or parameters. As you can see, list reverse, it reverses the objects in a list. You don't have to specify anything. It already quote unquote knows you're just reversing the order, so there's no parameter to be passed in. List remove, well, we have to know what to remove, so you're going to specify an object. Likewise with count, the instances of an object. Max and min don't use the dot operator. You're just going to call the function max or min, and you're also going to have to specify in the parameter there the list that you are calling max or min on. And this is very, very similar to Java and JavaScript, which is why if you're already familiar with another programming language like those, you'll be able to pick up on it pretty quickly. And drag and drop from the options below to add Z to the end of the list and print the list's name. So we're going to add to the end. If we're going to specifically add to the end of the list, we can use the append keyword right there. And then we're going to print the list's length. So we're going to use the len, and then we're going to use, let's see, the end of the list. Okay, the list is named list, so we're going to go ahead and put list in there. Comme ça. There we go. Range. The range function creates a sequential list of numbers. The code below generates a list containing all of the integers up to 10. So numbers equals list range 10. And then print numbers, as you can see, 0, 1, 2 on. Now you notice it says 10, it's going to be 10 items, but because it's 0 indexed, the name of the last item is going to be the integer 9. The call to list is necessary because range by itself creates a range object, and this must be converted to a list if you want to use it as one. So this list is going to make sure we're creating a list, not an object. And what is the result of this code? Nums equals list range 5, and then print nums for the object at index 4. It should be 3. Oops, that's wrong. So see, at index 4, so that would be index, okay, so it would start at 0. It's not going to be 5. See, it's not 5. Okay, let me see. So let me see. List nums 4. So at index 0, it should be 0. Oh, so it's going to be 4. There we go. I was overthinking it a little bit. So the item at index 0 is going to be 0. The item at index 1 is going to be 1. The item at index 2 is going to be 2. And you can see where I'm going with that. If range is called with one argument, it produces an object with values from 0 to that argument. If it is called with two arguments, it produces values from the first to the second. So you don't have to start a range at 0. For example, here we have a list called numbers. The range is going to be from 3 to 8, and when we print the numbers, it's going to be 3 to 7. This is actually behavior that's demonstrated in other programming languages as well. For some reason, they've decided that we're going to include the first parameter, but we're going to go up to the second parameter, but not included. So it's not 3 to 8 inclusive, it's not 3 to 8 exclusive, it's 3 inclusive to 8 exclusive. So we end up getting 3, 4, 5, 6, 7, but not 8. And I actually have no idea why it's done that way, but it is, and it's done that way in more than one language. So I guess it's one of those things we just have to have the serenity to accept. Here, print range 20 equals range 0 to 20. And that is going to be true because these are different ways of expressing the same thing. The reason for that is because 0 range starting at 0 inclusive to 20, and if you don't specify, if you just have the one number, then it's automatically going to start at 0. So these are equivalent expressions, and that's why. And this comparator is asking if they are equivalent expressions, and since they are, it resolves to true, and we're asking it to print what it resolves to, which is why it appears as true in the console there. And what is the result of this code? Creating a list nums range 5 to 8, and then it requests that we print the length of the range. So this is going to be 5, 6, 7. It's going to include the 5, so it's 5, 6, 7. It does not include the 8. Because it doesn't include the 8, it's going to be range 3. And you might notice if we look at the greater number and then just subtract the first parameter from that, 8 minus 5 is 3. So range can have a third argument which determines the interval of the sequence provided. Third argument must be an integer. In other words, what we're looking at is what we've seen previously is it automatically starts at the first argument. If only one argument is provided, that automatically is 0. and it's been going up by 1 for each item, but it doesn't have to go up by 1. It can go up by a different amount. So here we've got range. We're going to start at 5. We're going to end at 20. The optional third argument, which is here in this case, is 2. So it's going to jump up by 2 for each item. So we're going to start at 5 and go up to 7, 9, 11, 13, 15, 17, 19. The next one would be 21, but 21 exceeds our second parameter of 20, so it's going to just stop at 19. And what is the result of this code? Nums list range 3 to 15 by 3s. So what we're going to have is 3, 6, 9, 12. The next number is 15, but we don't include the second parameter in the list, so it's only going to be 3, 6, 9, 12, which is 4 items. It's not asking us to count the number of items. It's just asking nums 2. So it's going to be 3, which is index 0, 6, index 1, index 2 would be 9, so it's actually going to be 9. I guess I didn't really read this very well. I thought it said length or len, but it's going to be 9, just like that. Be sure to actually read the code. A lot of times you can spend a lot of time programming a solution to a problem, but it's not the problem you were given. So it is important to read instructions carefully. And for loops, every language I've ever learned has had for loops. They're just ridiculously useful to have sometimes. I don't suppose it would be impossible, but it would be difficult enough to have a language without for loops that you might not want to mess with that language. So expect to see for loops in some form, minor syntactic differences notwithstanding, in just about any language you study. So sometimes you need to perform code on each item in a list. This is called iteration, and it can be accomplished with a while loop and a counter variable. Here we go. Words, counter 0, max index equals len words minus 1, and then while. So we have word equals words counter, print word plus, and then the exclamation point, counter equals counter plus 1. So we're going to increase that counter each time. When we reach the max index, it says less than or equal to. So when we reach the max index, which is the length minus 1, because it's 0 indexed, it's going to execute, but then we're going to increase it by 1. After we've increased it by 1, it's no longer less than or equal to. And when that condition is false, then the while loop terminates. So hello world spam eggs. Eggs is the last one, and we're done. And I'm not sure why they say for loops. I guess they're about to introduce the for loop, which is an easier way to do this same thing. Which construct can be used to iterate through a list? Well, we can use loops. And here it is, the for loop. Iterating through a list using a while loop requires quite a bit of code, so Python provides the for loop as a shortcut that accomplishes the same thing. The same code from the previous example can be written with a for loop as follows. Words equals hello world spam eggs. For word in words, print word plus the exclamation point there. So it's going to be hello world spam eggs. It's a very different looking for loop than what I'm familiar with in Java, JavaScript, and C++. I wonder if I'll see the for loop in Python is like the for each loop in other languages, and we do see for each loops in like Java and JavaScript. fill in the blanks to create a valid for loop. So we've got our letters. So this would be for is that correct? For in letters. That's correct. Why is this an I? Or is that a pipe? Print L. Oh, I see. Yeah, I see how it is. For L in letters, print L. This is basically a variable name that we're using for each of these items here. It doesn't matter what it is as long as it matches here and here. I'm like 95% certain that that's the case because for X in Y is a convention that's used in other languages. So this for each structure, which actually uses the for each language in some, or I should say for each terminology in other programming languages, but it just uses for and it uses the keyword in Python. So you can use anything you want right here as long as it matches what's right here. Okay. The for loop is commonly used to repeat some code in a certain number of times. This is done by combining for loops with range objects. For I in range 5, print hello, and you see it iterates over that 5 times. That range object, this is very different syntax from for loops in the other languages that I've studied. So this is pretty interesting. We're kind of taking a diversion away from what I've been familiar with. For loops in C++, JavaScript, and Java are almost identical. There's almost no difference at all, and it's quite different from this. So this is actually pretty interesting for me. You don't need to call list on the range object when it's used in a for loop because it isn't being indexed, so a list isn't required. Alright, that is interesting. Fill in the blanks to create a for loop that prints only the even values in the range. So for I in range 0 to 20, and we're going to print I. Now remember, in the range object we're starting at 0, we're going to 20, but not including 20. Only the even values. So we're going to do this, and that third parameter is going to be 2 because we're going to increase by 2 each time. It says only the even values. In case you're wondering, 0 is even. Okay, and a simple calculator. Calculators are simple to use, not always simple to program. From a programming perspective, they're not actually very difficult to program, but for someone who's just learning a language. But this lesson is about an example Python project, a simple calculator. Each part explains a different section of the program. The first section is the overall menu. This keeps on accepting user input until the user enters quit, so while loop is used. So we see while, then true. This is going to be an infinite loop, but we don't want it to run for infinity. So what we're going to do is we have this break condition right here. If user input equals quit, then we break. Let me see. That's interesting. So what we're going to do is we're going to print options, and then it's going to print enter add to add 2 numbers, enter subtract to subtract 2 numbers. These are all our instructions for the user, and each of these print statements is going to print on a separate line. And this is explaining to the user how to use the calculator. If you enter quit, then it breaks out of the loop. Else if you input add, and we've got an ellipsis here. And I'm not sure what the ellipsis does. I've never encountered that in Python before. I assume they're going to elucidate that for us soon. If we were to replace the break statement in the code with a continue, what would happen? Let's see, well, it would run forever, because if we continue, it's just going to send us to the top of the loop. The top of the loop says while true. Well, true is always true. So if we can only continue and not break, then it runs forever. If you quit twice to exit, that's not going to work. It wouldn't run in exactly the same way. Well, no, because it doesn't have a break condition, so it doesn't work, doesn't run at all in the same way. Okay, creating the calculator. Next part of the program is getting the numbers the user wants to do something with. The code below shows this for the addition section of the calculator. Similar code would have to be written for other sections. So lf user input equals add num1 equals float, and then we have input enter a number. Num1 is the variable name of our first variable, the number. Float is declaring the type of variable it's going to be, and then we have the assignment operator here. So the input keyword is going to accept input, and we have a prompt here for our user. And then we do the same thing with a second variable that is creatively named num2. As it is, this code crashes if the user enters a non-numeric input. When prompted to enter a number, we'll look at fixing problems like this in a later module. So for right now, if the user plays nice and puts numerical data in, fine, and it crashes otherwise. Why are the calls to float necessary in the code? Well, it converts the user input to a float. Doesn't remove spaces. Check if user input is a number. It doesn't check to see if it's a number. It just casts the input as a float. If you try to cast non-numerical data as a float, that throws an error, so it would crash. And the final part of the program processes user input and displays it. The code for the addition part is shown here. So we've got the code that we had before. We're getting that input. The result is a variable, and we're going to assign to the result variable using the assignment operator num1 plus num2. Now we could just do, I'm almost certain we could just use num1, num2, but we're going to have to convert that to a string. In this particular code, they converted to a string here. We could think we could have printed it out, but then we'd have to convert it to a string down here. Since it's already a string in this code, then we just concatenate. The answer is, and then remember that space there so that it's not squashed together with the number is displayed. And then concatenation operator results. And we now have a working program that prompts for user input, then calculates and prints the sum of the input. Similar code would have to be written for the other branches, subtraction, multiplication, division. The output line could be put outside the if statements to omit repetition of code. So fill in the blanks to make the calculator work for multiplication. So we're checking for input as multiply, and then inside the code block float input enter number. Num2, well, this is going to be cast to a float as well. And then num1 and num2, the operation to be performed is multiplication, which is indicated with the star or asterisk. The result contains a string, so we're going to be casting those floats into a string, and then print the answer is, we've got a space there, concatenator, and then the name of the variable containing the result is result. And more ads. Calculator. Oh, okay. Looks like we're ready for Module 2 quiz. And here we go. What is the output of this code? Lists. It's got 1, 1, 2, 3, 5, 8, 13. And that's interesting. See, list. Oh, okay, I see what they're doing here. So we've got a lot of symbols of enclosures here. So what we're going to do is when you have multiple nested enclosures here, what we're doing is we're going to work from the inside out. Okay, so we're going to print the item from list for the index. Oh, we've got another list here. So actually we need to work this one out. So list index 4 is 0, 1, 2, 3, 4. Okay, that's the integer 5. So instead of list 4, we're going to use 5. So it's list index 5, and that is 0, 1, 2, 3, 4, 5. So list index 5, which is list index 4, is 8. And we're going to print 8. And let's see if I did that right or I got lost somewhere. Oh, it's correct. This is not at all unusual, so I'm going to keep an eye on the things like that. What does this code do? For I in range 10, if not I modulo 2 equals 0, print I plus 1. Okay, so we've got this range. It's going to be 0 to 9 inclusive, or 0 inclusive to 10 exclusive. So it's 0 to, starting with 0 and going to 9, including 0 and 9. If not I modulo 2 equals 2, it equals 0. Okay, I modulo 2 equals 0 is going to be all even numbers. Okay, that would include 0. Okay, now here we've got not, so it's going to flip it. Okay, so it's going to be all odd numbers, and then we print I, the odd number, plus 1, which is going to be all the even numbers. Now we're starting at 0, so it would be the even numbers. It should be between 1. No, it says 0 to 8. Maybe we'll include 0. What happened? It's the even numbers, though. Pretty sure. Yep, starts at 2. Okay, so if we walk our way through this code, okay, the first one is 0, okay? 0 modulo 2 equals 0. Okay, well, it says not, so we don't do anything with that. 1 modulo 2 equals 0 is false, but we flip it to true, so we execute this code. And then 1 plus 1 is 2, so it starts at 2. When we go to 2, 2 modulo 2 equals 0, which is true, then we reverse it to false, so we don't do anything. When we get to 3, again, this total statement would resolve to true, so we do this. 3 plus 1 is 4. So even numbers between 2 and 10. How many lines will this code print? While false, print looping. Well, false is always false. So if it's false, then this while loop never executes. So it would be 0. Fill in the blanks to print the first element of the list if it contains an even number of elements. So we got an even number of elements here, but we need to make sure that we can see that. But what if instead of 4 we had 10,004? We can't look at the list and just count them. So if list, what's here? Well, we're looking at how many elements it contains. So that's going to be len. Okay, so if len list, and then what we're doing here is modulo 2 equals 0. All even numbers, when you take the modulo 2 of even numbers, it always ends up as 0. Okay, so that's what we're doing here. And what do we end if conditional statements with? Well, that's going to be the colon. Okay, and if it contains an even number of elements, print the first element of the list. So the first element would be index 0, like that. And what does this code output? Letters X, Y, Z. Okay, now what we're doing here is letters, and then we use the dot operator to call the insert function or insert method. A method is a function. A function is not necessarily a method, though. So letters dot insert. We got two parameters here. One means the index that we're going to place it in, and index 1 means the second element. So we're going to put it right between the X and the Y there. And then the value that we're going to place in that index there. So instead of X, Y, Z, we're going to have X, W, Y, Z. And then print letters 2. So X, W, Y, Z. X would be 0, W would be 1, and then Y would be index 2. So that would be Y. And last one here. Fill in the blanks to iterate over the list using a for loop and print its values. Okay, so we've got our list here declared. Okay, and this would be for variable in list, and then we use the name of the variable. We named it var. For var in list, print var. And there we've done with control structures. So next lesson we are going to pick up with functions and modules. And obviously I assume we're going to be doing a lot more with functions, maybe be introduced to more functions or writing custom functions. I've never done anything like that with Python, but I kind of really have to assume you can create custom functions and methods. It just wouldn't make sense if that's not the case. I'm not sure what the word modules refers to in the context of Python. We've seen from lists, which in other languages are called arrays, that sometimes the terms for what is exactly the same thing aren't always exactly the same. So I'm looking forward to learning what modules are, and I hope that you explore that with me. It looks like this is the end of the course, so the certificate there. So we've got our functions and modules, exceptions and files, more types, functional programming, and that's a lambda, in case you didn't know that. Not familiar with your Greek alphabet, that letter is lambda. And I know what lambdas are in other programming languages, and I'm pretty sure they're probably almost exactly the same in Python as well. A section on object-oriented programming, regular expressions, which can be infuriating when you're learning them, but can turn out to be extremely useful once you've got a pretty firm hold on it. Pythonicness, I have no idea what that is. And packaging. So looks like it's going to be a lot of fun, and we're going to pick up with functions and modules in our next lesson. Thanks so much for joining us here at Cajun Coding. I appreciate it. If you guys have any questions, concerns, comments, critiques, anything like that, leave those in the comments on the channel. Thanks again. I'll see you guys next time.